let's jump now into some of the audience questions. We've got one here from Dr. Doug McLean. He's got a PhD in applied math and works as the lead data scientist at a food company in the UK called Greggs, which is famous for its delicious pastries, though they have lots of other foods as well. But anyway, so Doug, technical guy, he's got a good technical question here. He says, could you make sure Robert comments on Judea Pearl's ladder of causation? So rung 1 is association, rung 2 is intervention, doing, and rung 3 is counterfactual. And so there's some terms there that you mentioned counterfactual in some of your other responses, but you might need to dig into the definition of that a bit for our audience. And so the reason why he's asking you to comment on this ladder of causation, again, rung 1 is association, which I think is kind of like correlation. Rung 2 is intervention, so the kind of being able to make some assumptions about causal effect. And then rung 3 is counterfactual. He says, to be blunt, I'm really stumped when it comes to causal modeling. It seems you need to know what to expect first before running any analysis. So I guess he's kind of basically saying here that, to like this ladder of causation or the way that you set up causal models, there seems to be like often to set up the model effectively, you already have to have some understanding of what's going on. And he finds that confusing.
Yeah. And so to answer that last point directly is that, I'd say that you want to model, I think oftentimes the way that people are trained to think about data, particularly again in an industry where we unfortunately often have less control over how the data is collected, so causality is kind of asking you to think more about the data generating process than the data. And so when you don't actually have control over that process, it can get a little bit frustrating because it's kind of out of your hands, right? But so typically we kind of get some data set. We're thinking about like, okay, well, what are the transforms I should apply to this? Maybe I should discretize this. Maybe I should apply a log transform to that. Right. So we're thinking directly in manipulating the data to make it more amenable to the models that we want to use. And causality is saying like, data aside, you need to tell me what your assumptions are about the underlying data generating process. So now going to the causal hierarchy, I go into it very extensively in the book. I'd say probably more so than any other book. And so we're really, so again, at level 1 of association, we're just kind of plain old vanilla statistics and correlation land. And then level 2 intervention, this is what we're talking about, say, when we're trying to emulate an experiment, when we're asking what if questions, like what if I were to take this vaccine, would it prevent me from getting sick? And then level 3 is counterfactuals, and here we're asking questions where we're imagining what might have been different. So, say for example, I didn't get vaccinated and I got sick. Would I have gotten sick had I been vaccinated? So this is actually the same as kind of level 2, which is say, what if I had taken the vaccine? What if I take the vaccine? Would I get sick? But now we're going to condition on two pieces of additional information: the fact that I didn't take the vaccine, and the fact that I did get sick having not taken the vaccine. Right. So in level 2, I'm saying, what if I take the vaccine? Will I get sick? And level 3, I'm saying, what if I take the vaccine? Or putting aside tense, putting aside present tense, past tense. Say A, take the vaccine. B, get sick, yes or no. But now we're going to condition, and so that's the same as the first case. But now we're going to condition on 2 extra things: the facts that had you not, that's given not A, that not B happens, right? And so the counterfact, and the reason we call it counterfactual is because either the hypothetical condition, taking the vaccine, or the hypothetical outcome, getting sick or not, is in conflict with some data that we've actually observed, which just makes it a bit more challenging to model. But at the same time, we're still just conditioning on some extra evidence. And so, in terms of like, what is required to make those types of assumptions, answer those types of questions, requires very generally speaking, some additional causal assumptions. Some of those assumptions can be specified entirely in the form of a DAG, and then some of them can't. Often, frankly, the more interesting ones can't rely on DAG-based assumptions alone. We need to make additional assumptions about mechanism. But if him being a mathematician who understands things, like for example, you might make so not only there's A cause B, which you can represent with a graph, but maybe you make the additional assumption that B is monotonic in A, right? That's for a change in A, there's a corresponding change in B, and that change is constant, or that change is going in one direction no matter where you're at with A. And so so it's just asking for more assumptions, but it's not asking you to know the answer. It's just asking you to say well, if for certain questions you can get away with lesser assumptions, and for certain questions you need to make a few more. And so we can think about our assumptions as falling out on different levels of the hierarchy. And so you might sometimes, for some interesting questions, you need to make level 3 counterfactual assumptions.